In the third and final question of this series, where we use chemical formulas as conversion factors, we're expected to answer the question: butane, which has the chemical formula C4H10, is a liquid fuel used in lighters. How many grams of carbon are in a lighter containing 7.25 milliliters of butane when the density of liquid butane is shown right there? This is the first time in this series where they actually give us the total in milliliters as opposed to as a mass, which in question 2 was in grams and in question 1 was in grams as well. So what we should do from the start is convert 7.25 milliliters of butane into grams using its density. So let's go ahead and multiply 7.25 milliliters by this conversion ratio, and be careful how you orient the conversion ratio. Obviously right now it's in grams per milliliter, so that's good, but in case it was the opposite way, you can flip it as you wish. So I'll multiply this by 0.601 grams per milliliter. And notice how convenient it is because the milliliters cancel out, leaving us just with grams. Using my calculator, I'll take 7.25 and multiply it by 0.601, and we end up with 4.35725. 4.35725, and keep in mind that everything after this 5 is insignificant, although I'll continue to work with these three numbers following this 5 just to prevent any sort of rounding errors. So now that we have the amount of grams, and we're sort of on the same page as question 2 where they give us the grams, the next thing that we did in question 2 was find the molar mass of one molecule. So I'm going to find the molar mass of butane, and I can do that by taking the molar mass of carbon, which happens to be 12.01 grams per mole, or AMU, atomic mass unit, and multiply that by 4 because there are 4 of them. Hydrogen has an atomic mass unit of 1.008 grams per mole, and I'll multiply that by 10. So let's use our calculator. We have 12.01 times 4 plus, and make sure that you put each calculation in brackets, that way your calculator doesn't get confused. And we end up with 58.12 grams per mole of one molecule of butane. Now I'll take this number and multiply it by the mass of this liquid, which was 4.35725, and keeping in mind that we should have 3 significant figures. Notice right now I made a mistake. Notice that I put grams at the same level of grams. So what I have to do is flip this. I have to flip this number where I have 1 mole over 58.12 grams. The reason why I kept the mistake is just to give you an idea that if you don't flip the molar mass correctly according to what you're trying to find, you will end up with the wrong answer. So now that I flipped it, now I can multiply it by 4.3572 grams. This cancels out with this, and I can use my calculator now to find the number of moles because that's what's remaining. I have 4.3572 divided by 58.12. And this gives me 0.07496. 0.07496. Everything after this 9 is insignificant, although I kept this 6 because I don't want to run into any errors. I found the number of moles of 4.35 grams of butane. Now what I need to do is find specifically the amount of carbon. And the way I can do that is by multiplying this by the molar mass of carbon times 4. The molar mass of carbon was 12.01 grams per mole. If I multiply that by 4 and apply this to my expression here, I end up with 12.01 times 4 grams per mole. Notice that the moles will cancel out, leaving us only with grams. So let's go ahead and use our calculator. This number times 12.01 times 4, and we end up with 3.60. 3.60 grams of carbon. That is how much carbon exists in 4.35 total grams of this butane. And there you have it. That is how to use chemical formulas as conversion factors. If that question didn't make sense to you, go back to question 1 and then back to question 2 and see if it will make sense to you the second or third time around.